Okay, then let's continue. Thank you, Hal, again.
Sure.
With the second speaker, Professor Rami Abou Jamra. He studied medicine in Damascus, completed his PhD and residency in Bonn, and gained further scientific and clinical experience in Erlangen and Rostock. His focus is the genetics of intelligence impairment, as well as the development of new applications for routine diagnostics. Since 2000, Department, the Institute of Genetics at the University of Leipzig Medical Center. Welcome, Rami.
Hi, thank you. Do you have a pointer? Okay. So, fine. Thank you very much. And yeah, some disclosure. Some information that must be said at the beginning of a commercial session. And in addition, please, I have on one slide patient photos. Please don't make pictures of that. And I wasn't aware that it's going to be streamed, so it's pity. But I appeal to the people behind the screen not to make any screenshots. That would be marvelous. Thank you. First case. I must stay very near here. So first case is how we missed a C01 mutation. And this child is at the age, photos at the age of 6 months and at 3 years. And at 3 years, the whole clinical spectrum was developmental delay and renal dysplasia, insufficiency, megacyst, undescended testicles, hypospadia, inguinal hernia, and also microcephaly, trigonocephaly, facial dysmorphism, cleft palate, and secondary hearing loss. In addition, there was also heart failure, and the family history was normal. Well, there was no family history of similar disorders. And although the child looks like you should find diagnosis, we didn't manage to do that in the first step, unfortunately. So what happened is already prenatally, it was clear that there is something. At the 18th week of the pregnancy, there was reported genitourinary malformation with pelvic kidneys and megacystis. And karyotyping has been performed, but also TrueSight1, which is, for people who don't know, a big panel of about 5,000 genes, and this was negative. The child is born, and at the age of 2.5, can I use the mic? Good. Yeah, I mean, can you hear me well as well like that? Okay, good. Fine. At the age of 2.5 months, it was clear that we need to do a reevaluation, and we have done that, and also we didn't find anything. We reevaluated the TrueSight1 data, and the reason is that this gene is not covered. CNOT1 is not covered in the panel, and the lesson that maybe everybody of you know in the meanwhile is don't use panels. They are never complete. They are never complete. So at that time, we didn't have a big machine enough to do larger things, but it was not a nice thing that we didn't do that. However, even if you are doing exome, you still can do failure, as we have done, because in May 2019, there was 2 publications on this gene telling that this gene is associated with holoprosencephaly and with developmental delay. And a few days after that, we have performed a trio-exome sequencing, and we have seen this deletion, but we didn't realize that it makes sense. The deletion is big enough, so there is no way to miss it. And at that time, there was no possibility to have an automatic annotation of this deletion, because the gene was still not officially connected to the phenotype, so you needed to go to PubMed and check that, which we didn't do because at that time we didn't realize that it was de novo. The picture that you see here on the left that shows that you can see that the child has a deletion, obviously, and the parents, the mother and the father, don't have the deletion. This is something new, and at that time, you needed to go out of the patient and then go to the parent and then go out and go to the next parent, and a mixture of, well, the gene is not known and it's a little bit too much work, and most importantly, the gene was associated with neurodevelopmental delay, which we didn't realize as a symptom. Our information was that there was some malformations, but we didn't assume that there is developmental delay, so we missed that at the age of 3.5 months, and later on, at the age of 3.5 years, they came for a re-evaluation. At that time, we had the pictures, and when you see the patient the first time, you would say, okay, holoprosencephaly would fit perfectly. But if you don't have this information, this is a little bit tough. And also, the information of developmental delay was clear, and we could then see this deletion, that it's de novo, and that is the cause of the disorder. So that wasn't a nice story, but yeah, that's the reason why I'm telling it to you, because this is going to be repeated now with a gene that's still not known, and when you are performing an exome, well, you should go for a genome. Second example is Anna, born in March 2015, and she has a mild developmental delay, Asperger syndrome, muscular hypotonia, feeding difficulties, and she has weakness of muscles, progradient, and painful, recurrent swelling of joints, fingers and knee, and a mild creatine kinase elevation. We have performed an exome sequencing, and this was negative. For people who don't understand German, the most important 3 sentences in this very long text is, we performed exome sequencing, we found nothing, and we are now going for a triexome sequencing in order to raise our yield of the diagnostic. And what we have found is a de novo variant in the gene KMT2B. We have actually seen this variant in the single exome analysis, and at that time, as we have done the single exome analysis, we thought that the phenotype doesn't fit because this is a gene that would cause dystonia. And we also weren't very sure if it's de novo or not. And as we have made the trio exome analysis, it was clear it is de novo, but we still thought that that doesn't fit. It's a different phenotype. And we thought that we didn't find the cause, but this is, of course, wrong. And the report didn't go out of the institute because what one sometimes need, and that is an experience that a lot of my colleagues who are new or not physicians, that mean a lot of people working in the genetic diagnostic are biologists, and they are doing a great job. But at some time, we need to take care of some small nuances. When you read that, when you go to OMEM, and I tell everybody, if OMEM is not your reference, OMEM is only to give you the first glance so that you follow the line, but you can't rely on that. If you go to OMEM, you would see this gene causes dystonia. You have a child who has hypotonia and developmental delay, and then you disconnect. But indeed, you may have, or you have some proper symptoms, as an example, the CK elevation and also the developmental delay. This is a common failure, and often we can find it before it goes out of the lab, a variant that's relevant that you thought at the first instance that it is not, and in the second glance it is obvious. But of course, what I can tell you are the cases that we didn't realize, and they are already out and wrong. So that's the report, and it looks strange to have a KMT2B associated dystonia 28, childhood onset, in a phenotype of neurodevelopmental disorder, but that's the naming of OMEM, the official naming of OMEM. And the variant would still be of uncertain significance, even if it's de novo, it's a missense variant, and there are no further aspects that would support it getting to be likely pathogenic or pathogenic. And you don't need to read the text, but the final part of that we see a partial overlap of the symptoms and think this may be relevant. And in such cases, we always recommend to come again in a few months to see how the child develops and which novel information we are going to get about the variant so that we can grade up or maybe admit another mistake by reporting that and going back, which in this case, I think it's not probable. A third example, there was an amniocentesis at the 26th pregnancy week in a child or in a pregnancy with intrauterine growth retardation. Yvonne, you tell me 3 minutes before the time out? Yeah. Hypoplastic nasal bone, reduced fetal movements, and other symptoms. And we have performed the so-called FAST test, where you test for the common aneuploidies of chromosomes 13, 18, 21, and X. And this was inconspicuous. So we made a report out telling that we found nothing in that. There was no aneuploidies, but we said that there is a contamination, a maternal contamination of 15 to 30%, because this test is very quick. You do it on the native cells from the amniocentesis. That's the translation, no hints for aneuploidies, maternal contamination, but we went further for exome sequencing. This is this FAST test, and I don't know, I'm not going to go into details of the method, so if you don't know the method, which is microsatellite markers, I'm sorry, but for people who know that, you would obviously see that, especially in, this is a good example where you have 3 alleles, one of them is from the mother, and that's the contamination, and this is not very rare, but even after we have cultivated the cells, we are still seeing that there is a contamination from the mother, which doesn't make sense if you have cultivated cells. And this is how it looks in varvis. I don't know, do you see anything? Can you guess what we have? The problem is the BVAR quality was bad. So it is just a little bit below the level where we would repeat the whole exome sequencing using fresh material usually. And in this case, I don't know if you can see, but there is a small elevation of the whole chromosome of this child. It is not directly on the middle line. And there is no chance that you can evaluate this based on NGS, not in our time, because that is how it looks like. There is no normal cells because either we have a trisomy 22 or we have a triploidy. And indeed, it's a mosaic, And yeah, indeed, it's a mosaic of XXX 23 and also the trisomy of chromosome 22. And this can be easily then seen in the allele frequency plotter, where you can see that the father and the mother are on the middle line, and while you have this split of the alleles of the allele frequency due to this triplication of the phenotype, of the karyotype. Another case that we have missed and then catch up later is this child. The child has symptoms of albinism, and in 2018 we have made this panel, and it was normal. And then we have made a quattro exome in 2020, and this was also without positive finding. However, we have found a variant in the correct gene, but we have found only one variant, and this is an autosomal recessive phenotype. And we looked a lot and find nothing else. So what we have done is we went for genome sequencing, and that's how it looks like. And genome sequencing is doing CNV. It's a dream. It's so nice. It goes like that, and you don't have this background, and it's such a big difference. I mean, we are going to jump over to genome sequencing mostly because of the comfortability doing the CNV analysis, because the exome sequencing, doesn't matter how good you do it, you still have a lot of background, and this background is really painful. It's really painful because every time I close a CNV analysis negatively, I'm thinking, was it really negative or did I oversee it? And when we have some new colleagues, you need to teach them over a couple of months that no, you cannot validate every deletion of one exome that you see because most of them are actually artifacts. And to your question about the sensitivity, we have made an analysis. We have compared exome sequencing and array, and we have found that starting by 3 exons, it is 100% perfect, and 2 exons is good, and 1 exon, it's practically not doable. Unless, of course, I mean, if you have a very specific diagnostic, you are checking only 3 or 4 genes, then it makes sense. And this deletion, or these 3 deletions in the genome sequencing are actually very interesting, because we went then back to the literature, and it wasn't new. We just didn't know about that. It's an inversion of the chromosome 3 to 19, and this inversion is not inverted at the same position, but it is inverted and inserted between exons 1 and 2, that means in intron 1, leading to some small deletions and to this structural variant. I also thought there are also the very normal pitfalls that happen to everybody of us, so I thought to show you some examples. As an example, what a good example is a CNV and a duplication. In the pregnancy, there was a suspected heterotaxy syndrome, and the amniocentesis, the genetic diagnostic, was inconspicuous, which is, I think it was only a chromosome analysis. It was not at our lab at that time. So the child is born, and later on, it was seen that there is a renal hypoplasia, renal failure, heterotaxy syndrome, and other symptoms. And we have found a heterozygous variant in the gene IFT140. And it's very rare. It's good quality. It affects the protein. It has a good overlapping of the phenotype. So it made sense, but it was only one variant. And this is an autosomal recessive phenotype. So we checked again the CNV analysis, and we have seen here a duplication of, luckily, 4 exons. Duplications are much more difficult to be identified, and the region is a nice one. It's pretty quiet, so that's the only reason why we found it. And I think that we are missing a lot of such compound heterozygosities, because as soon as you have it a little bit more noisy, then you would say there is no chance to validate everything, and then you would jump over. Another pitfall that you should take care of is the IKBKG gene, the pseudogene, and if you have a phenotype, you have no chance to find it unless you really check it extra. So it was also a case we reported back negative, and then the physician said, "Are you sure? It should be positive." And then we needed to talk about the symptoms and which differential diagnosis the physician has. And by the time you have the differential diagnosis, you can then recheck and find it. This supports the importance of the interaction with the physicians and also their clinician opinion. And another case that is also risky and can be missed are genes that are not very convenient. In this case, we have found a deletion of several exons. The deletion makes sense, it's obvious, but we had some issues. We didn't want to believe in that because the PLI was low, and maybe you know if you have a low PLI, then there is no worries of losing the gene, and when you see such a thing, then you expect, okay, that doesn't make sense, it won't be pathogenic, and but we checked then with Decipher, and we found there was comparable deletions that were reported as being pathogenic. And even if the PLI is low, we have seen that there is a phenotype already associated with that, but with the urinary tract malformations, and we needed to go back to the physician and get some further information, and then, oh yeah, the child has some malformations, and then we were able to report the gene. And this is a case that we would have missed if we didn't talk back to the physicians. And sometimes we talk back to the physician, and sometimes you just call him 2 times, you don't find him, and then you say, okay, a negative report, which is also a pitfall that we had, and I assume that everybody of you also had a couple of times. So in summary, of course, you always do your best. We also do our best. but you must be prepared to miss variants. And I think that if everybody of you miss a variant and then find it again and share that with the rest of us, then we would have a better chance that we miss less variants in the future. And of course, what I showed you are variants or cases that we finally or eventually have solved. Which I can show you are cases that we haven't solved and that are still running around without diagnosis, although this should be possible, or even with a wrong diagnosis. I thank everybody at the Institute of Human Genetics because these cases are not my cases, but cases that have been contributed to me by my colleagues. Thank you, all of you, and I thank you for your attention. If you have any questions, I'm ready to answer. Thank you.
Hello, my name is Sarah Delbare. I'm from the University Hospital of Ghent, Belgium. I'm wondering if you're confirming the small duplications you found, the CNV duplications, the smaller ones. Do you confirm them with a second technology? And if you do so, which one is it?
I'm not aware if we have done this for this specific duplication. For a duplication of 4 exons for a fitting phenotype, in such a quiet area, we don't necessarily confirm it. We find it good enough. If we had to confirm that, then we first check if we have MLPA, and if there is no MLPA on the market, then we do qPCR, which is unpleasant.
Would be my next question.